A 5 kilogram block in contact with a 3 kilogram block are pushed along a frictionless table top with a force of 16 newtons. And we've been asked to find the force which the 5 kilogram block applies to the 3 kilogram block. In other words, what is the force, the unbalanced force experienced by the 3 kilogram block? Now you might think it's going to be 16 newtons, but that's not the case. The first thing we have to do is find the overall acceleration of the system, and we're going to define the system as the 5 and the 3 kilogram block joined together being pushed with 16 newtons. So the acceleration of the block would be simply equal to the unbalanced force acting on the system, that's the 5 and 3 kilogram block, divided by the total mass of the system, which is going to be the 5 and 3 kilogram block. So we have 16 newtons divided by a mass of 8 kilograms, and we're going to get an acceleration of 2 meters per second every second. So the system is going to accelerate at 2 meters per second every second. So each part of that system will have the same acceleration, which means the 3 kilogram block is going to experience an acceleration of 2 meters per second every second. And the 5 kilogram block is going to receive an acceleration of 2 meters per second every second. Now, in order to find the force experienced by the 3 kilogram block, we isolate that 3 kilogram block just like this. Now that it's isolated, we can see that the 3 kilogram block has an acceleration of 2 meters per second every second. And what would be the force needed to do that? Well, all we have to do is put down force equals mass times acceleration. What will be the force needed to accelerate a 3 kilogram mass by 2 meters per second? And we get the answer of 6 newtons. So the force the 3 kilogram block experiences is 6 newtons. So that must mean that the 5 kilogram block pushes the 3 kilogram block with 6 newtons. Now we can do the same with the 5 kilogram block. What unbalanced force does that feel? Well, once again we isolate the system, just like this. And you can see we have a 5 kilogram block accelerated at 2 meters per second every second. So the force required to do that, use Newton's second law again, F equals ma, which equals mass of the block, 5 kilograms, times 2 meters per second every second, and we see that we're going to have a force of 10 newtons, an unbalanced force of 10 newtons acting on the 5 kilogram block. So here we have the 16 newtons pushing these blocks, and yet the 5 kilogram block experiences 10 newtons, and the 3 kilogram block experiences only 6 newtons. So what exactly is going on here? Well, because the two blocks are in contact with each other, there has to be what we call a Newton pair of forces. And to see this better, we're going to look at the 5 kilogram block on its own. Now the 5 kilogram block is pushed with a force of 16 newtons. So 16 newtons pushes the block, 16 newtons. Now, because the 5 kilogram block pushes the 3 kilogram block with a force of 6 newtons, the blue block, the 3 kilogram block, will push back with a value of 6 newtons. That's what we call a Newton pair. Let me say that again. The 5 kilogram block pushes the 3 kilogram block with 6 newtons, and therefore the 3 kilogram block will be pushed back on the 5 kilogram block with 6 newtons. So the unbalanced force acting on the 5 kilogram block is not 16 newtons, it actually is only 10 newtons, and that will give the same acceleration equal to 2 meters per second every second. So in the case of blocks touching each other, we have to be very wary of the Newton force pairs, action and reaction taking place at the same time.
Physics is wonderful. Physics is cool.
A 5 kilogram block is attached to a 3 kilogram block with a very thin piece of string, which in this case is considered to be massless. And that's very important in these problems, and you can find out from another video why we've got to consider the piece of string to be massless. Both are connected by this little piece of string and are pulled along the frictionless top table with a force of 16 newtons. And our job is to find the tension in the string, and we'll call that tension T. Remember, tension is a pulling force. It's the force which travels all the way throughout the string, and it is a pulling force. Now, to find the tension of the string, the first thing we have to do is find the overall acceleration of the system. And we consider the system to be the 5 kilogram block, the massless string, and the 3 kilogram block. So what's the overall acceleration then? Well, we find that by using our acceleration formula from Newton's second law. Acceleration is the unbalanced force acting on the system divided by the total mass of the system. We're going to have unbalanced force is 16 newtons, and we're going to have to divide that by the total mass of the system, which is 8 kilograms. And that's going to give us an acceleration of 2 meters per second every second. Now, what does that mean? It means that the system is going to increase its velocity by 2 meters per second every second. But we want to find out the tension in this piece of string. Now, to do that, we have to isolate the 5 kilogram block. And we know that the 3 kilogram block is going to be accelerating at 2 meters per second every second. And so is the 5 kilogram block going to be accelerating at 2 meters per second every second. So we isolate the 5 kilogram block, and we know that it's going to experience an acceleration of 2 meters per second every second. And this must be because of the tension in the string. So the tension is going to provide that force to accelerate the 5 kilogram block by 2 meters per second every second. So we can say the tension can be found by saying mass times acceleration, just the same way as Newton's second law. And the mass is 5 kilograms, we've isolated it, times its acceleration, which is 2 meters per second every second. And therefore we're going to have a tension force of 10 newtons. So the tension force in the piece of string is actually 10 newtons. And that's how easy these problems are. Here's another problem involving these blocks on a frictionless surface. We have a 5 kilogram block, a 3 kilogram block, and a 1 kilogram block, all tied together with these very light pieces of string, which we are considering to be massless. And they're pulled along the tabletop with a force of 27 newtons. And what we're asked to find is the tension in the string between the blocks. And we'll call that here tension T1, and we'll call that there tension T2. Remember, tension is a pulling force which acts between these two blocks because the string transmits the force. So how are we going to find this tension 1 and tension 2? Well, the first thing we have to do is find the overall acceleration of the system. And the system comprises of the 5 kilogram block, 3 kilogram block and 1 kilogram block. So the overall acceleration of the system can easily be found. Acceleration is the unbalanced force pulling the system, in this case 27 newtons, divided by the total mass of the system, which is going to be 9 kilograms. So we've got 27 newtons divided by 9 kilograms, and that's going to give us an acceleration of 3 meters per second every second. So that's going to be the acceleration of the system. Every block in that system will have the same acceleration. So the 5 kilogram block will have an acceleration of 3 meters per second every second. So will the 3 kilogram block, 3 meters per second every second, and so will the 1 kilogram block, 3 meters per second every second. Now, we're asked to find first of all tension T1. So once we know tension T1, we can look at the 5 kilogram block and we can isolate the 5 kilogram block just like that. So that's the 5 kilogram block isolated, and you can see that it's going to experience an acceleration of 3 meters per second every second. We can isolate the block because the block doesn't know what's in front of it or what's behind it. It just senses the acceleration. So we've got a 5 kilogram block accelerating at 3 meters per second every second. So therefore the tension T1, the pulling force needed to do that, is going to equal to mass times acceleration. We'll just leave out the units and put in the actual numbers. 5 kilograms multiplied by an acceleration of 3 meters per second, and you can see that tension T1 must be 15 newtons. So that's the tension 1 done, it's 15 newtons. But what about tension 2? Now tension 2 is the pulling force in this light piece of string which is responsible for accelerating not just the 3 kilogram block but the 5 kilogram block behind it. So we isolate that system, you can see that we've got a 5 and a 3 kilogram block being pulled with a certain tension, certain force, which is going to give the system 3 meters per second of acceleration. So we do the exact same thing again, we just have to say T2 is equal to the mass times acceleration, and the mass that's accelerating, be careful, is not 3 kilograms, it's all the mass behind it. 5 plus 3 is 8 kilograms, multiplied by the acceleration of 3 meters per second every second. We'll leave out the units. So therefore T2 must have a value of 24 newtons. Now you can see why that's the case, because tension 1 is just responsible for accelerating 5 kilograms. So when you look at the 8 kilogram one, tension T2 is responsible for accelerating 8 kilograms. So obviously that has to be a bigger force to give it acceleration of 3 meters per second every second. So that's us found tension 1 and tension 2.
Physics is wonderful. Physics is cool.